Okay, here are the trig problems from lesson 53, and these should help you prepare for the the quiz in class on December 1st. I'll just go through them and we'll see how it's done. So, solve the following equations given that theta is between 0 and 360. Alright, so you're looking for where the sine of theta is square root of 3 over 2. So to do that, you have to look at your unit circle, and sine is the y coordinate. So sine is square root of 3 over 2 at 60-degree angles. Alright, so it's going to be in the first or second quadrant. That will be positive. Down here, it's going to be negative, so we don't want those. We just want this one, the 60-degree, and this one, the 120. So it will be at 60 or 120, so that will be our answer for that problem. So theta will be 60 or 120. So where's my pen? Theta equals 60, 120. Those are the only choices between 0 and 360 for theta. That's the only time that sine is square root of 3 over 2, is at 60 or 120. Okay. Number 11, you've got cosine 3 theta minus 1 equals 0. The first thing you want to do is add 1 on both sides to get the trig function by itself. So you've got cosine 3 theta equals 1. Alright, so you're looking for a time when cosine is 1. So if we look at our unit circle, cosine is 1 when the x-coordinate is 1. So the x-coordinate is 1 right here at 0 degrees. There's no other place that the x-coordinate is positive 1 unless you spin all the way around to 360, but in these problems we're saying less than 360. Actually, I think I put less than or equal to, but in the book it's supposed to be less than 360. So, yeah, so it can only be 0. 0 is the only place where cosine is 1. So we will say that 3 theta, not theta because it says cosine 3 theta is 1, that means that 3 theta must be 0 degrees, which means that theta must be 0 degrees. So, but there are other choices now because 3 theta has to be between 0 degrees and 360. So 3 theta could be between 0 and 3 times 360. So we have to look at other possibilities. If you were to put in, so what we do is we look at the argument, and that's 3 theta. So what we're going to add to what we got is 360 divided by 3. So we'll add 120. So it should also work at theta equals 120, because when theta equals 120, 3 theta is 360. So cosine 360 minus 1 is 0. So that works. And then we can spin around again and try add 120 again, and that would give us 240. If we put in 240 for theta, 3 theta is going to be 720, which is, 720 is back at 0 again. So there are 3 choices for theta here, because theta can be between 0 and 3 times 360. So you can keep spinning around. If you try to spin around again, add one more 120, you're going to get 360, and we're not really supposed to have 360. It's supposed to be less than 360. So there are 3 choices. When you have a coefficient on the argument here of theta, you can add 360 divided by that number until you get all the values of theta between 0 and 360. So sine theta over 2 minus 1 equals 0. So again, we want to isolate the trig function. Sine theta over 2 equals 1. Add 1 on both sides. So if sine theta over 2 is 1, we're looking for where sine is 1. Where is sine 1? Sine is 1 here at 90 degrees. That's the only place that you're going to get the y-coordinate being 1. So if we say that theta over 2, which is the argument here, has to be 90 degrees, that means that theta, if you multiply both sides by 2, is going to be 180. Now, you can't find any other values between 0 and 360 for theta that are going to work. Because if you spin around the circle again and you go to 360 plus 90, that is 450, and then if you multiply that by 2, then you're way out of range. So that's the only possible answer, is that theta would be 180, because look, think about it, plug it back into the equation. Sine of 180 over 2 is sine 90, which is 1, and that is what we're looking for. Okay, here we are just evaluating some trig functions, some squared trig functions at certain values. So if f of x is cotangent squared x and g of x is secant squared x, find f of negative pi over 3 minus g of 0. So f of negative pi over 3 is going to be cotangent squared of pi over 3. I'm sorry, negative pi over 3. And then g of 0 is going to be secant squared 0. So this is what we're really trying to solve here. So we're looking at cotangent negative pi over 3. Where is negative pi over 3? Negative pi over 3 is down here at negative 60 degrees. You're going clockwise pi over 3. So it's down here, and we're looking at cotangent. So cotangent is x over y. So it's 1/2 over negative square root of 3 over 2. So we'll put that in. It's 1/2 over 1/2 over negative square root of 3 over 2, and we're supposed to square that. So we'll get that figured out in a second. And then secant squared 0, if we look at 0 degrees, and we're looking at secant is 1 over sine. 1 over cosine, sorry. So it's 1 over 1. So that will be just 1. So secant squared 0 is 1 squared. Alright, so 1/2 over negative square root of 3 over 2 is just 1 over negative square root of 3, and if you square it, it's 1/3. So 1/3 minus 1 is equal to negative 2/3. Here we've got another one like that, where we're going to evaluate these functions at these values. So if f of x is secant squared x, f of negative 3 pi over 4 is secant squared negative 3 pi over 4. And then we're going to add g of 13 pi over 6. So that is going to be cosine squared 13 pi over 6. So we're just going to evaluate these trig functions at those places. So first of all, we want to look at the secant of negative 3 pi over 4. So we're going to go to negative 3 pi over 4. So it's 1, 2, 3 pi over 4 is right here. And we're looking at secant, which is 1 over sine. So it's 1 over this, which is negative square root of 2. If you take the reciprocal of this and then rationalize it, you get negative square root of 2. So that is going to be for secant here. So negative square root of 2, and then we're squaring it. And then cosine of 13 pi over 6. Sorry, I forgot the pi. Cosine of 13 pi over 6 is 13 pi over 6 is just 12 pi over 6 would be 2 pi. So you'd spin all the way around the circle, and that would give you 2 pi. So that would be 12 pi over 6, and then 13 pi over 6 puts you right here. So you're looking for the cosine, which is x. So it's square root of 3 over 2. And so we go here. Square root of 3 over 2 squared. So that 13 pi over 6, if you can think about just reducing the fraction, it's 2 and 1/6. So 2, if this is pi, you're talking about 2 and 1/6 pi. So that means you go 2 pi, which is spinning all the way around the circle, and then go 1 more pi over 6. So it puts you at 30 degrees. And that is where cosine is square root of 3 over 2. And then you just square these, and you get 2 plus 3/4. So it's going to be 8/4 plus 3/4 is 11/4. And those are the trig problems from lesson 53.